Okay, 108.3, the exercises. There's certainly some preliminary information given here just about notation and certainly some examples where I'm taking difficult examples like pi and the golden ratio. Um, the problem set, though, for the most part, it follows from the examples that have been brought in prior and certainly the content. Let's walk through this. And my understanding of walking through a problem is going through it one step at a time. And we want to do a continued fraction of this. The first thing to note is that 118 over 91 is actually an improper fraction, and 91 goes into 118 one time with a remainder of 27. All right? Then what you do is you take the reciprocal of 27 over 91, and we'll get to what the continued fraction looks like a little bit later. But this is the general process. All right? Now, you understand that A1 is 1. We'll go through this in a moment. Well, now, when I take the reciprocal of 27 over 91, you get 91 over 27, which is an improper fraction. 27 goes to 91 three times. 3 times 27 is 81, so you got a remainder of 10. All right, then what do you do? Well, A2 is going to be 3 then. And again, we'll get to the continued fraction in a moment. We're just going through the algorithm to get to it. Now you take the 10/27s, you can take the reciprocal of it. You get 27 tenths. 10 goes into 27 two times with a remainder of 7. Now the A3 is going to be 2. Take the reciprocal of 7 tenths, you get 10 sevens. 7 goes into 10 once. Remainder 3. Reciprocal again, 7 thirds. 3 goes into 7 twice. Remainder 1. Now someone says, excuse me, why did you stop there? Well, if you were to take the reciprocal of 1/3, what number would you get? You would get 3. So 3 equals 3. There is no fraction after that. None, all right? That's why we stopped there. So what do we do now? We're going to write the continued fraction down. And as I do that, I want to emphasize what we're looking for. And I'll do this one step at a time. A1 was 1. Let me erase this business over here. Let me get a different color, highlighter. A1 is 1. And then it's going to be 1 plus, it's going to be 1 plus a fraction, A2, which is 3, plus 1 over, a fraction that is, right? 2 plus 1 over. You're going to get 1 plus 1 over. And then what do you get over there? You get 2. And what's left over? That 1/3 business. All right? Now, they're asking for the 5 convergence. All right? So let's go through this one step at a time. And I want to point out what we're seeing over here. The first number I'm receiving, let me point that out to you, is the number 1. Right? So that's right over here. By the way, don't worry about what I'm saying about this thing being less than or greater than. Don't worry about that. The next one's 1/3. Put this over here. There's a 1 and a 3 over here. Now you have to understand what that means to me. 1 and 3 actually means 1 plus 1/3. What's that going to give me? 4/3. And that's right over here. All right? Now someone says, what's the next one going to be? Well, I got something that looks like this over here. 1 plus 1, 3 plus 1/2. All right, let's go through the work. All right, there's other ways of doing it, but let's just go through the simple stuff first. Let's see. What do you get in bottom there? We're going backwards, by the way. That's going to be 7/2. This would be 1 plus 2 sevens. That would be 9 sevens. Whoops, 9 sevens. All right, keep going through it. Let's do the next one. 1 plus 1, 3 plus 1 over 2 plus, well, it's going to be 1 over, what was that again? 1 over, can't really remember what that was. Let's see, we did the 3, we did the 2. Oh, just 1. I got that over there. And let's do the arithmetic on that. And let's see, 3 plus 1/3. Did I do that right? Yeah, I think so. 1 plus 1, 3 plus 1/3. 1 plus 1, that's 10/3. 1 plus 3/10, which can be 13/10. Whoops. 13/10. It's a little tedious. I want to point out notationally, though, it's really not that bad. All right? So, again, I really don't like doing a computation, but you can continue with that. So what am I really writing down? 1, 3, 2, 1, 2. Writing down those, no, oops, sorry about that. Let me get my highlighter out. You notice I'm just clipping a number off each time. Where these numbers coming from? These things. That's all we're doing. That's it. All right, let's go to the next problem.